Hello everyone, welcome to this video. In this video, we will discuss the second part of DNA block. The first part of this chapter is already given in the channel, so you can go and check out there. In this video, we will pick up the reactions part where you all face problems is that you all cannot remember the reactions. So I will tell you very easy trick to even remember the reactions and balance it. Okay, you will find it very easy in your exam to score 2 marks which comes from here. If it comes from 2 marks, then 2 marks. If it comes from more, then more. These are simple 2 marks from this reactions part. Okay, so let's begin. We have two type of reactions. One reaction we'll study about. I'm just writing the brief idea. One reaction we'll study of KMnO4. Other reaction we'll study of potassium dichromate. That is K2Cr2O7. Right? This is called potassium permanganate. And this one is called potassium dichromate. Right? Potassium permanganate, potassium dichromate. Okay. We will study this reaction under three categories: acidic medium, basic medium, neutral medium. And here we will study only in acidic medium. Though it was supposed to be all the medium study, but in your neutral book it is given only for acidic medium. So we read only those reactions only that is given in the book. Okay? Achha. Let us start with the first step, that is potassium dichromate. Okay. Potassium dichromate. First is industrial preparation of K2Cr2O7. K2Cr2O7 is prepared industrially from chromite ore. From chromite ore. Which ore? Chromite ore. How to remember? Chromite ore is chromium is present. So chromium is not present in KMnO4, right? KMnO4 does not have chromium. So chromite ore is having the name of chromium, so it cannot be manganate. It has to be dichromate. So chromite ore is dichromate, and chromite ore's formula is FeCr2O4. Okay? Clear? Now how to prepare this? See, the reactions of this part and the next part, that is KMnO4, are more or less similar. Just we will change the reagents. That's all. It will be similar. Only the change. First step. Always remember, in the first step we cannot prepare dichromate. In case of dichromate, the first step prepared is sodium chromate. So the first step you have to react the ore, that is FeCr2O4, in presence of 16 NaOH plus 7 O2. I remember the balancing also this way. 16 NaOH plus 7 O2. So the product form will be 2 Fe2O3 plus Na2CrO4. You can understand that Na2CrO4 means sodium chromate. Okay, and 16 NaOH means 8 Na2CrO4 and water. Sorry, not water. Water will not be formed here. Carbon dioxide, CO2. Okay, so FeCr2O4 plus 16 NaOH plus 7 O2 forms 2 Fe2O3 plus Na2CrO4 8 times plus 8 carbon dioxide. Balance the equation by multiplying a 4. So in the first step, we are preparing sodium chromate. Next step, we will go from chromate to dichromate. So this reaction will happen. Na2CrO4 plus H2SO4. That also concentrated H2SO4. So if I react this, then what will I get? See, sulfate is there. That means I will definitely get one product as my sulfate. So the required product Na2Cr2O7 plus another extra product Na2SO4. Okay, plus water. Okay, now see the balancing I think is not done, so this will be 2. Right, balancing I think is done now. Hydrogen 2, sulfate 1, done. Chlorine also 2 done. Oxygen 8 plus 4, 12. Oxygen 8 plus 4, 12. 4, 5, 12. Done. Clear? So in the first step, from the chromite ore, we are reacting it with 16 NaOH plus 7 oxygen. So we are getting oxidized value of Fe2O3 plus sodium chromate plus carbon dioxide. Second step, we prepare dichromate, it is sodium dichromate. So 2Na2CrO4 plus concentrated H2SO4. So since sulfate is there, therefore the product will also have one sulfate, that is Na2SO4, Na2Cr2O7 and water. Clear? The third reaction is basically the conversion of sodium dichromate into potassium dichromate. So we will write Na2Cr2O7 plus KCl forms K2Cr2O7 plus NaCl. Done. This is the entire three-step reaction of preparation of K2Cr2O7 from chromite ore, and this can be asked in the exam as a direct question. That please write down the how will you prepare potassium dichromate from chromite ore. Clear? Now let us come to the reactions. Now many of you try to memorize the reactions, but what is the product? You will not be able to even predict what will be the that what is the product, then you will be able to predict also. Clear? So I will give you one base reaction following which all the reactions will fit into that category. One or two might not fit, then I will tell you that you have to remember that reaction only. Rest, balancing also I am telling you, you can easily do it on spot without wasting time. You need not worry that I have forgotten what is redox reaction, or I have forgotten how to balance using I-Lepton method, I have forgotten how to balance using oxidation number method. No problems. You can balance on spot, see the equation only, I am telling you. Okay. So the first and the foremost syntax that you have to remember is this syntax. Please remember K2Cr2O7 whenever I am giving it with H2SO4. Okay. K2Cr2O7 plus H2SO4. Balancing of this reaction I am not doing because this balancing will change according to the reaction. So K2Cr2O7 plus H2SO4 whenever I am doing, please remember in this case it is minus 14 plus 2. So this will be plus 6. Correct? Plus 12 plus 14. So this plus 6 chromium oxidation state will this side go to Cr2SO4 whole 3. That is plus 3 oxidation state. Clear? So chromium goes from plus 6 to plus 3 oxidation state. Then how many chromium was there? 2 chromium. So what is the total number of change of electrons? 6, not 3. Okay. This is also done in class 11. So the total number of change of electron will be 6, not 3. Okay. Because 2 chromiums are there. This short question might be asked in MCQ or somewhere else. Okay. Acha. So the product will be Cr2SO4 whole 3. Another product will be K2SO4. That is potassium sulfate. K2SO4 plus water. These products will be common in all the reactions. So you find, you can easily remember it. These products are common in all the three reactions. Which product will change is the next part, that is 3 oxygen. This will be varying according to the reaction. This is what you have to remember, that when you are reacting K2Cr2O7 with H2SO4, what happens? 3 nascent oxygen is evolved. So that 3 nascent oxygen will cause your balancing to get more proper. Now let us do the reactions so that you can understand. Okay, so here you remember that number of electron change equal to 6, right? Number of electron change is 6. So equivalent mass of K2Cr2O7 will be divided by 6. Clear? I think K2Cr2O7 is 158. No, that's K1O4. Fine. Whatever is the mass of K2Cr2O7 divided by 6 will be the equivalent mass, because you know equivalent mass is equal to molar mass by n factor. Achha. Now let us start with the reactions. The reactions we have in our syllabus. Okay. K2Cr2O7 plus let us take out H2SO4 plus Ki. What is this? Potassium iodide. So potassium iodide is -1. So iodine can go to which state? Minimum 0. Correct? The minimum next value is 0. So iodine will try to go to 0. First 0, because iodine does not usually go to plus. So iodine will first tend to go to 0. Then how many oxygen are available? 3 nascent oxygen. Then how much I2 will be produced? 3I2 will be produced. Okay, so first let us write these products. Cr2 SO4 whole 3 plus K2SO4 plus water plus 3I2. Clear? So how much iodine is produced? 3 iodine is produced. So 3I2. So what will I write here? 6Ki. Done. One balancing done. Acha. Next, see. Cr2SO4O3 done. K2Cr2O7. So Cr2 done. K2 is done. Okay, fine. What I have to balance? Now how many sulfates are available? Sulfate 1 and sulfate 3. So let us assume 4 sulfates. 4 sulfates. Done. Achha. Now how many hydrogen? See, only hydrogen available is here. So how many hydrogen? 4. So this also must be 4. But you can understand that you have made a mistake. What mistake? This type of balancing you have to do in the exam. Now we will do this way. See, 3 and plus 1 4. So let's write 4. But there is a mistake. What is the mistake? You have to keep your eyes and nose very open. You can see 6 potassium here and 2 potassium here. Then how did you put 4 over here? Because this side 36 to 8 potassium and this side only 2 potassium. So potassium has to be made 8 first. Right? So potassium I have to make it 8. So I have to put a 4 over here. So if I put a 4 over here, I have to put a 4 first. Then my total sulfate will become 4 plus 3, 7 and not 4. Clear? So this is how you are going to change the equations and balance it accordingly. 7. So this will become 7. Then now you see the equation will be balanced. Now you see the equation will be balanced. See, K2 plus 6, 8. 4 2s are 8. Done. 7 2s are 14 hydrogen. 7 2s are 14 hydrogen. Done. Achha, next iodine. 6 iodine, 3 into 2 iodine. Done. Balancing done. Easy. Might take a 1 or 2 minutes, but it will give you a legit correct answer. Okay, if you try to memorize, it might give you a wrong answer. It might have a chance of giving you a wrong answer in the exam. So please make sure that you don't do that. Okay. Next reaction. K2 Cr2O7 plus H2SO4 plus FeSO4 ferrous sulfate. Okay. So what will be formed? The common products Cr2SO4 whole 3 plus K2SO4 plus water plus 3 times. So ferrous plus 2. So this will go to plus 3. So this will go to Fe3. Sorry. Fe2SO4 whole 3. Done. How many? 3. So 3 into 2, 6. So can I write 6? Now you see. Sulfates. How many sulfates are here? 9 sulfates. How many sulfates I have written over here? 6 sulfate. Previously if you see, I have written here 4 sulfate and I have written here 3 sulfate. Total I have added 7. No problem. But here you see, here I have taken 3 into 3, 9 sulfate, but here I have written only 6 sulfate. So if I am going to consider, it is going to be lesser, right? This value is lesser than this, na? So 3 more you have to calculate. Don't forget that 3 more. Here you have put 6, then don't think that these are all done. Calculate 3 plus 1, 4, done. So I will put a 4 over here. Your answer will be coming wrong. Clear? Why your answer will be coming wrong? Because you have not checked it properly. If you write it over 4, then you will find your balancing is not coming proper. Again, you will waste 5 minutes more on that. So please, first check properly. See, here you have put only 6 sulfates, but here you have put 9 sulfates. Then 3 deficit already you have created. This side 3 deficit sulfates are already there. So 3 sulfates along with these 2 sulfates. 3 plus 1, 4. So total how many sulfates have a deficit of there? 7 sulfate deficit. So this is 7. Clear? This 3 plus 1, 4 and plus 3 from here. So total 7 sulfate deficit is over here. Understood how to proceed with the question? Okay. How to proceed with the question? You have to proceed in this way with the question. Clear? So this is 7H2. So this will be 7. Done? Understood? Understood? Easy, but you have to be a little bit alert, because if you don't be alert, then you will make up a mistake. So please keep your eyes, nose, ears open and do the question. It's a very, if you know how to balance properly, you will find it's easy. Okay, next K2Cr2O7 plus H2SO4 plus H2S forms same product. First let me write the common products. Cr2SO4 whole 3 plus K2SO4 plus water plus H2S will form sulfur. How many sulfur? 3 sulfur. Right? A sulfur is in minus 2 state. So minus 2 to state forward 0. Sulfur goes to plus, that's fine. But here it cannot go to plus. It has to go first come to 0. So there will be how much sulfur? 3 sulfur form. Done? Acha. Now let us check for the sulfate. Acha. Balancing ke kono gandagol nahi. No gandagol in balancing because there is no problem of sulfate over here. Done? So 3 plus 1, 4 sulfate. So 4 sulfate. Done? So 4 2s are 8 hydrogen. So shall I write here 4 hydrogen? Then again my balancing will go wrong. Why? Why? Because here you see 4 hydrogen, but here also hydrogen is there. Previously there was no hydrogen over here, but this time there is hydrogen here also. So how many hydrogens are available? 8. 3 sulfates from here, so this will be 3. So 3 into 2 6 and 8. So this will become 7. This will become 7 because 3 also here. Clear? See? 3 into 2 6 and 4 into 2 8. So 8 plus 6 14. So 7 2s are 14. So 7 water. Clear? Clear? Easy. How long did it take? Easy. 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 Okay. Next we will go to the next person. Acha. One more question can last time it was asked in somewhat your I think so selection exam only. They gave you oxalic acid with K2Cr2O7, but it was not given in your book. How to balance oxidation number of in your book you will find it is given with manganate, but it is not given with K2Cr2O7. Then how will we proceed with K2Cr2O7? Let's just check it out. Okay, this reaction is not given in the book, so let's try it out. K2Cr2O7 plus H2C2O4. This is called oxalic acid. Okay, this is oxalic acid. Oxalic acid plus H2SO4 forms K2SO4 plus Mn. Okay, plus Cr2SO4 whole 3 plus water plus carbon dioxide. Now you see, bromine is plus 6 and has been reduced to plus 3 state. How many change of electron? 3. So I will put a 3 over here. Okay. Acha. Now you see carbon number 3 to the 6. So 6 carbon number. Okay. Then hydrogen how many? 3 to the 6, but I don't know because hydrogen is here also. So how many sulfates? 4 sulfates. So 4. So total hydrogen 8 plus 6 14. So 7. Done. Clear? So you see balancing is done so easily. Even if you try to memorize them, you will not be able to. I'm saying you that you will not be able to, will forget it exam. But if you remember it this way, it will be very easy for you to remember. Okay. Now we are coming to the next topic, that is potassium permanganate. Potassium permanganate, that is KMnO4. Actually, preparation of this is done from pyrolusite ore. Preparation of this is done from pyrolusite ore. Pyrolusite ore is nothing but MnO2. Simple. Okay. MnO2. Pyrolusite ore is nothing but simply MnO2. Clear? So potassium permanganate is prepared from pyrolusite ore. On the other hand, potassium dichromate is prepared from chromite ore. Okay. The first step of the reaction remains the same as we have done before. This reaction is also the same. Just we will use KOH instead of NaOH. Simple. Okay. So MnO2 plus KOH plus oxygen forms 2K2MnO4 plus water. This time only water will be formed. Acha. Balancing I think is 4 KOH. 4 KOH 2 MnO2. And I think 2 will be put here also. Another 2 will come here anyway. 4 plus 4. 8 oxygen. This side how many oxygen? 4 plus 4 is 10 oxygen. 10 oxygen to have na. Then 8. This side 10 na. 4 plus 4 8 plus 2 10. This side 8 2. Done. I think done. Balancing is also done. Okay. So this is the first step. First step of the reaction. So you can see this step is resembling same as the previous step. There also we have used same procedure, but it was NaOH plus oxygen. This time it is only KOH plus oxygen. Done. Next we have second step where we will change this K2MnO4 into KMnO4. So K2MnO4 plus. How to change this? Using oxidizing agent. Okay. So we will use carbon dioxide or chlorine. All are oxidizing agents. If you use carbon dioxide, okay. If you use chlorine, that is also okay. Okay. I think using chlorine will be much easier because that will be a shorter reaction. So K2MnO4 plus chlorine forms KMnO4 plus KCl. Okay. Please check the balancing. I think is not done. This will become KCl. This will become 2KMnO4. So this will become okay. So KMnO4 2 to the 4 2 to the 4 done. Manganese done 2, oxygen done 8, silver done. Okay, clear? Clear? So first step 2MnO2 plus 4 KOH plus O2 forms 2 K2MnO4 plus 2 water. Second step 2 K2MnO4 plus chlorine forms 2 KMnO4 plus 2 KCl. This is pyrolusite of the preparation of potassium permanganate. Okay, just try to relate. If you try to memorize and repeating, if you try to memorize short, you are going to mess up. Guarantee you will mess up. So what you are going to do? You are going to use these small tips and techniques to save your time in the exam and to get good marks in chemistry. Okay. 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 Now let us come to reactions. As I already told you before that for potassium permanganate we have different set of reactions. What do I mean by different set of reactions? I have under three categories, three set of reactions. So first we will read about basic reaction, that is in basic medium, then neutral medium, then alkali medium. Okay. First you have to know how to identify whether it is a basic medium or it is an alkalic medium. First you have to know what is a basic medium, what is an alkali medium, what is a neutral medium, what is an acidic medium. So as you can understand, in alkali medium there will be alkali, in acidic medium there will be H2SO4, in basic medium, in neutral medium there will be only water, nothing else. So how to identify? If you see that it is given KMnO4 plus water, only water, then it is a neutral medium reaction, because there is one reaction which will confuse you on this case only. Next, if you see it is given KMnO4 plus KOH, it is given KMnO4 plus KOH, then this is a basic medium. Okay, and if you see KMnO4 plus H2SO4, which you will see mostly, this will be an acidic medium. Okay, this will be acidic medium. But what am I telling you? Basic medium and neutral medium, basically they are same. They are same means their products are same. So you need not remember them as two separate things. Their products are same, entirely same. Clear? Actually, KOH you will ultimately not get in basic medium. Whenever you are writing the basic medium equation, there also will find you are writing only water, because ultimately if you write the main reaction, no, the KOH part gets cancelled out, because in the product side also the KOH is formed. So that will also get cancelled out. So ultimately you will not find anything present over there. Okay. Right? So you have only one reaction to study under neutral medium, that you will please memorize that reaction. That is the reaction which you have to study under basic medium, not neutral, sorry, my bad. Under basic medium there is only one reaction which you have to study, and which you have to memorize that reaction. That reaction is a little bit different from others, so you have to memorize that particular reaction. Okay, otherwise you will get to know the reactions. Right? Let's start. The first reaction. Okay, first reaction, it is in neutral medium reaction. So KMnO4 plus, let me see the question, KMnO4 plus hydrogen sulfide, KMnO4 plus hydrogen sulfide. So this is a neutral medium, so you can see no base or acid is present, only KMnO4 plus H2. Reactant will be anyway given in the question paper, so that you can see. So KMnO4 plus H2. What will happen? I did not say the main reaction only. So first let me speak about that. I forgot. Okay, see, KMnO4 plus plus, let us say plus water. Okay, in neutral medium, this is in neutral medium. In neutral medium, your product will be MnO2 plus KOH. Always remember, if on the right side you have water, left side you will never have water. If on the right side you have water, then on the left side you will never have water. And on the right side if you don't have water, the left side you will definitely have water. So here you are having water on the right side. So on the left side, no water molecule and 3 oxygen will be produced. 90% will be full. Clear? So what did you understand? In neutral medium, if water is on the left side of the reaction, then right side no water is produced. Clear? Similarly, if water is on the right side, tricks which you can just remember like that. Okay, next, if I talk about basic medium, then also the reaction does not change, it is same reaction. So basic medium, alada kore you need not remember anything, same reaction, MnO2 plus KOH plus 3 oxygen. But this reaction I will put a star mark because you did not remember this syntax, you will just remember one reaction and I will tell you that means the only reaction present over here. Okay, and acidic medium, KMnO4 plus H2SO4 forms K2SO4 plus MnSO4 plus water plus 5 oxygen. Okay, this time you have to remember this is 5 oxygen. Only 5 oxygen present for acidic medium of KMnO4. Done? Now let's start with the reaction. These are the 3 steps that you need to just remember. So alkali medium or neutral medium, product is same. The common products are same. Okay, so let's start with the first reaction that we have. KMnO4 reacting with H2S. As you have seen, it will be oxidized to sulfur. How many oxygens are produced? 3. So 3 sulfur will be seen. So first product is, this is a neutral medium. So you have a first product in the form of KOH. Second product you have in the form of NO2. Water present on left side? No. So in product there will be water and you will be getting 3 sulfur. So 3 sulfur means 3 I will put over here also. So 3 into 3 sulfur done. Achha, how many hydrogen available here? Hydrogen I have to calculate over here. Like this I cannot say hydrogen. Like this I cannot say hydrogen. This side how many oxygen are there? 2 plus 2 4. 2 plus 2 4. But hydrogen valency is not done na. 6 hydrogen and this side you can see 2 and 3 hydrogen. Achha. Then what I can do is 6 hydrogen. This side I cannot change. So let us put a 2 over here. Then 2 hydrogen plus 2 hydrogen, 4 hydrogen. Oh no, I need 6. No. I need 6. 6 only. 2 plus 2, 4 plus 2, 6. Correct. My brain is not working on it. 2 into 2 is 4 plus 2, 6. So 6 hydrogen done. So 2 I need to put over here also. So this 2 will come here also. Oxygen balance, 8 oxygen, 2, then 2, 4, plus 4, 8. Done. Clear? So balancing done. So you can see neutral medium, the left side no water, right side just put water. Done. Second reaction. This reaction is very important. I am writing with a different color pen because this reaction is a different from the other reaction. We have to memorize this reaction. KMnO4 plus Ki plus water. This question can also come in KMnO4 plus Ki plus H2SO4. That is acidic medium Ki. That works as K2Cr2O7 plus Ki reaction. But this is in presence of basic medium. But this indicates a basic medium. You can say that it indicates a neutral medium. But this is actually a basic medium reaction. Anyways, that's fine. So this reaction, you remember, this reaction is different from the other reaction. The product of this reaction, the common products are KOH and MnO2. The common products are KOH and MnO2, but the third product is KiO3. This is a very important reaction, KiO3. Why it is KiO3? Because 3 oxygen here, 3 nascent oxygen makes 1 KiO3. Okay, that is why we are not writing a 3 in front of it. 3 oxygen needs for making KiO3. 3 oxygen you can say joins Ki. So 3 oxygen needed there only na. So we will not put a 3 extra over there. Clear? So KiO3, no 3 in front of KiO3. Then now just put the balancing. How many Ks are there? 2 Ks are there. So let's put 2 over here. So 2 KMnO4, then 2 MnO2, then 2 K, no, 2 I will not put. 2 plus 1, 3. Okay. 2 plus 2, 4. 2 plus 2, 4. So here 2 K. নাকি না ব্যালেন্সিং গন্ডগোল হয়ে যাবে 2 plus 1 3 না এখানে 2 বসানো যাবে না তাহলে 2 plus 2 2 plus 1 3 2 plus 1 3. Okay, so 2 kmn upon 2 plus 1 is 3. So let us put 2 over here. So I will get 2 kh, 2 plus 1 3 done. Oxygen, how much it is this side? 8 plus 1 9. So 2 plus 2 4 plus 3 7. 7 oxygen this side. 7 oxygen and this side 9 oxygen. This side 7 oxygen. This 2. Oh, okay, okay. Mn2 is missing. Correct. Done. Done. Now it's done. 2 plus 4 8. 8 plus 1 9. Then 2 plus 4 6 plus 3 9. Done. Clear? So this reaction is very important because this is a little bit out of box reaction. KMnO4 plus Ki plus water forms 2 KOH plus 2 MnO2 plus KiO3. 3 oxygen needed for making 1 KiO3. Okay. Next reactions are very easy because this reaction already you have done over there. Same, just products are changed. So KMnO4 plus H2SO4 plus Ki. So product you all know 5 times. This time it is 5. Okay. So K2SO4 plus MnSO4 plus 5 plus water plus 5 times I2. That is plus 5 times I2. So this will become 10 times Ki. Okay. This will become 10 times Ki. So 10 times Ki means definitely I have to put a 2 over here, otherwise it will not match only. 10 plus 1 11 10 will not work. So 10 plus 2 12. 12 12 12 6. Right? 10 plus 2 12. Then 6 K2SO4 will work. 2 MnO4 will be here. So 6 sulfate plus 2 8. So 8 8 8 8 8 8 8 8. Clear? Done. Easy, right? Number 4. KMnO4 plus H2SO4 plus FeSO4. So what will be my product? K2SO4 plus MnSO4 plus water plus 5 times Fe2SO4 whole 3. 5 times SO4 whole 3. Now you see how many again. For same case I am telling. Last time also I told you, this time also I told you. Sulfate count, please keep in mind what is the sulfate count. Okay, see here. How many sulfates you have put? 15 sulfates you have put. Okay, so how many sulfates you will put here I will see. So how many? So here I can see 15 sulfates. So 15 sulfates are here. Acha. Now you see 5 into 2 iron, 10 irons are there. So can I write 10? Now moment I write 10, I can see that there are only 10 sulfates possible. So you can see that there are 15 here and 10 over here. So how many less this side? 5. More 5 this side. So 5 and here this K2SO4. So I have to write 2 over here. I have to mention 2 over here. So 2 sulfate plus 1 3 sulfate plus extra 5 sulfate over here. Plus extra 5 sulfate over here. Correct? So total becomes 8 sulfate. So here it will be 8. Here also it will be 8. Clear? So this is exactly how you are going to solve. This is exactly how you are going to balance the equation. Otherwise, even if you sit for eternity, you will find that you are not able to balance the equation. Okay? So next, equation number 5. KMnO4 plus H2SO4 plus H2S forms K2SO4 plus MnSO4 plus water plus 5 sulfur, right? Because 5 nascent oxygen. So 5 sulfur can I write over here? Okay. Now I will write 2 over here. Let us write 2 over here. So total 2 plus 1, 3 sulfate. So let us write 3 sulfate. Acha. Now hydrogen, how many? Let us check it out. 6 hydrogen plus 10. 6 plus 10, 8. So this will be 8. No, 6 is 8. 8. Correct. Okay. Done. So you can see it's very easy. It's very easy to remember and it's very easy to do it also. Okay. Acha. Next reaction that we have already done for K2Cr2O7, that reaction we will do now. that you have done in titration also. KMnO4 plus H2C2O4. Titration also you have done, plus H2SO4 forms K2SO4 plus MnSO4 plus 10 CO2 plus 8 water, right? 10 CO2 means 5. 10 CO2 means 5, right? And K2SO4 means 2 here, 2 over here. Sulfate how many? 3. Done. Clear? So these are the reactions that you have to read from this chapter. I hope that you all have understood how to do these reactions effectively. From this chapter, I think and I hope so that 2 marks reactions will be coming from this chapter. And if you have a strong grip of these reactions, then you will find that it is very easy to score this 2 marks from here. Others focus on the give reasoning questions, especially DD transition, complex formation, amenability of d orbital. These are the key points that you will try to miss out in the answer. And please read the question first. If it is given from the actinoid series, then mention effect transition. If it is mentioned from D block, then it will be DD transition. So this type of common sense you have to apply and don't rush during the exam. Okay. Okay. Bye bye.